I'm gonna take a break from the funk playlist to listen to some jazz funk. I would like something. That's probably my best bet. Well, I started the stream. How am I feeling? Kind of wanted to just watch TV today. But I did that yesterday and the day before. Those are my days off. So, back on. I'd love to make progress towards my long term goals of the Strafe client, but that's brutal. The work is brutal. Just insanely complicated. Oh yes, I did think of one thing I could do. The union's support for the Strafe client. That's annoying, not brutal. Why is it hot already? I'm gonna go open the window. We can listen to the Miami F1 race cars going by. Someone left a comment. Do you live in Miami? I can hear F1 race cars going by. I don't live in Miami. It's much more mundane. That's better. Wow. Got a breeze already. So, I'm definitely still upset about the hash stir thing being such a large project. Took a week, and then it just wasn't worth it. I guess it's. I haven't actually asked if they want to allow lifetimes on the public interface, but I expect that was the whole point of Euster, was that they were going to not do that. I was also thinking it would be cool to make my own. You know what? What is the file look like? Let's see. So API dump.json. API dump class. Name is class name. Classes. Property. Deprecated. What is this? Class name lowercase c. Oh. Bzz. 67,000. Hmm. 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 Classes and enums. You know what? What if it's a B tree map? I guess that's still like an in-memory data structure. You can't just construct it off rip. It doesn't matter. It doesn't matter. All right. So something I was interested in is read string. So this function is probably a decent portion of the time spent. I'm in the Skubert branch. The time spent. Good God, I wrote so much code. I just gotta throw it all away. That's not true. The time spent reading files is probably like 10% right here. So if we could like not do this copy, where it's copying the data from here into here, that would help a little bit. Be a little bit faster. Why do I care? Because I'm interested. I want to read about it. Rust read trait 0 copy. Yeah, this doesn't have a read trait though, does it? Like this is, if you already have a byte slice, then you can do this. Or something like this, but like less sucky. Fresh look. Wait a second. Oh, hold on, hold on. Alright, I got AI library. Let's see this. Okay. So do we think that'll fit? Hmm. Alright. Mm-hmm. 19 gigabyte. Oh. Why is that? Sick. Can I run a 27B? I don't know. 12B might be easier. Alright. Let's see. Where's the thingy? Do I have to reopen it? Oh. Oh, I see. Very nice. Okay. Default. Okay. Default. What? I don't know what that is. Okay. Lovely sirens all the time, every day, all day. Oh, cool. I can think now. Um, I guess it's not possible, is it? It's not possible to zero copy off the top of the read trait. You like in the read trait, you're given a buffer, but then you have to like do something with it. You can't just return it. Let's go look at the actual read trait. Rest read trait. Yeah. Okay. So you have a thing and then a buffer you're writing to. So it is by definition a copying operation. Hello. Vectored. IO slice mutt. What? Oh. You can slam. What? Transforms into an iterator over its bytes. Oh, I see. Hmm. Hmm. What is that? Borrow. Are these the same buffers? Oh no. It took a mutable reference. That's weird. I don't understand why you'd want to do that. Okay, so you'd want to not use this. So let's see if I can get this thing to tell me something. What is a zero copy alternative to the Rust standard library read trait? I don't know why I specifically wanted that on my clipboard. Control Enter. U. Loading up in the GPU. Zero copy doesn't literally mean no copies. I think it literally does. But it's not necessarily zero copies in the entire chain. It's zero copies in the section of the code you're trying to do. The idea is like you can create a reference to existing memory, a structured reference, without copying any data. Async read with pin memory. I don't think so. Read. That's just straight up a copy. mmap creates a virtual memory region that maps directly to the file on disk. Reads and writes to this region access the file directly without copying? How is that possible? Unsafe. Let's go. So is that like the entire everything is unsafe? Or just forget to add a... Oh no, there it is. Here. Can you put this on the side? There we go. Map shared read write prot question mark is like weirdly that length. That doesn't seem right. So it's not necessarily a files, but like this is so interesting. Virtual memory region. This is the old one. Why? I don't understand. So is it like intercepting your reads and writes? And then going and doing the file IO? So reading the memory just kind of suddenly blocks you in a unexpected way. Virtual memory. Yeah. Oh. Rip table. Can you even... So like when I first learned about the read trait in Rust, I looked at it and went, wow, that's really cool. You could totally chain readers together. You could have like something reading from network, and then it's like zipped or something, and then you have a streaming unzip, and then you have like streaming read the file. So you're like reading the file as it comes in from there, but you can't actually really do that. It doesn't really work like that. Like you need async stuff in there, or like state machines and state machine drivers, which like, yeah, it's not as powerful as I originally anticipated. And it's like guaranteed to copy, or it's not guaranteed, but it's like it's expected to copy based on the function signature. Like we look at the function signature, read self buff. So what you're expected to do is take data from here and write it to there. So it's necessarily a copy operation. What about copy? I want to see that. I want to see the implementation. Copy, 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 copy. Reader, writer. So you read bytes from the reader and write it to the writer. So is this like fancy? How fancy is this? Oh my. Kernel copy spec. Oh my. Generic copy. Buff spec. Okay, the user space read write loop implementation of IO copy that is used when the OS specific specializations for copy offloading are not available or not applicable. Interesting. That is rather fancy. This function will continuously read data from reader, write it into writer in a streaming fashion until reader returns and the file is returned. Cool. If you want to copy the contents of one file to another file and you're working with file system paths, see the fs copy function. Cool. Retried. On Linux, this function uses copy file range syscalls to move data directly between file descriptors if possible. So this is like what, digging all the way? I don't understand how that's possible. Very interesting though. I think that the best option is byte slice. Just reference to a slice of bytes. So that would change the library signature. Library signature, no way. So this guy, from reader, it'd be like, it'd be like from bytes. And then instead of reader and read, you would just go like, hey man, I got bytes. And that's it. And then you would know for sure that the whole file is in memory and you can access it. And it lives for a certain amount of time. You can include references and lifetimes and everything. I mean, you're wanting to make a new thing here, but oh well, like that would actually allow a different design. You would no longer need string internment if you're not using a hashed strings, which I think is better, even though I wrote a whole hasher library for this implementation. Yeah, that would basically be the best way, I think, is to like hold a reference to the bytes. I wonder if you can still conditionally untangle the lifetimes if you do it like that. Because like with the other implementation I did, I can have a one enum variant as static and the other enum variant holds the lifetimes for the strings. But if you had the bytes, you could just zero copy the bytes and then hold a reference to those bytes. And then the DOM is valid as long as you continue holding a reference to those bytes. And then you don't need a string interner. It would probably make a lot of libraries faster because you'd have to read the whole file, which is like way faster than just like on the just like requesting bytes as you need them in most cases using this. I poured milk and sugar on Friday, but then I realized I already had half a coffee in the fridge. So yeah, that's the milk and sugar from Friday now made into coffee on Monday. Hooray. I'm very good at reusing my old coffee. So I doubt they would want to make that change. I mean, unless it's like 2x speed. If it's like 2x speed, then like, hell yeah. Yeah, I don't think you can do it without changing the function signature. Like it is necessarily going to do a copy, but I guess you could save the allocation. Maybe I'll explore a scratch buffer. So doesn't like it. Okay, so let's try scratch buffer. So I think that there was a scratch buffer somewhere else. Oh, state. Who? Okay, so what's the read guy? Okay, so who has the reader? This guy. Okay. R input. Okay, so right here. Chunk decode. No way. So we're looking here. So I'm guessing that this is mentioned somewhere. Core. Read, write. Oh, jeez. Interleaved bytes. Oh man, profiling would probably be the best way to do this. If I'm actually trying to make it faster. StrafeNet wiki is down. It's been down for a long time. I don't know when, and we'll go back up because It's a Name needs to do that, and I've asked him multiple times. What is this code? Why do you need to? This is weird. Standing in large block PC building stream. What, did I build a computer a year ago? I don't remember that. Was I making it for someone else? Or was it just like tinkering with the parts? Push. Putis. Inconsistency. 21 PC build. Yeah, that That's a bit more than a year. Standing in a large box. I don't remember that. Ugh. This looks tradable, but so this is the operation to avoid. Especially for this one, because like most of the time it's just gonna go into a different type. Hmm. 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 Yeah, it's very incompatible. The read trait to Euster. I don't think that there's any functions to do that. You like Euster. So there's from stir. From into deserialize. Yeah, I don't really know how to do this. I guess the way is to make a new function called like read to scratch buffer or something. I guess you can literally do this. Readly. Read string with scratch buffer or something. Read into string. Do you feel a lot more familiar with the library's code base now? For sure, for sure. After working on it for a week and like refactoring the whole thing, absolutely. I can think of like where various things are and how to upgrade. Which like that's how I found out about this is just poking through. I'm like, oh, that's not good. That's a slow thing to do. This is you have to call this for every single property of every single instance. Mm. So reads all bytes. Yeah. So Uh, how many goobs does this do? So if key value, how many does it say? No. Okay. Fun. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 occurrences of this function. So these ones are not so bad because they're like stack allocated. You already know how big you want it. So you don't have to do an allocation. You're still doing a copy, but that's the read trait. That's what's going on. Hopped again to what? Another distro? Or to the forbidden operating system? Gen 2? No way. Well, my friend uses Gen 2 as well. He was an Arch guy for years. He's like, you know what? Screw it. I'll just do it. And I don't know if he's gonna stick with it, because like when he moved, his PC blew up and he had to fix the whole thing. Metadata chunk. So insert key value, metadata, deserialize your state. Is this? Oh my. Loop. Oh my. Tinkering. I was bored with Arch. That's crazy. Arch is like pretty demanding if you're new to Linux. Gotta turn it up a notch. Not really new to Linux? Oh, okay. Data. Well, hold up. Wait a minute. Wait a minute. Wait a minute. Wait a minute. Hold up. Wait a minute. So it's doing. We have bytes, and then we're going like, oh no, just copy it, instead of like doing the goodness. This is probably a very cold function that gets called like once, but still doing stuff. Let's see, where's that search I did? Oh my god, there's so many things already. Oh my god. Okay, cool off. Let's do read string with a lowercase s. This function is safer than read string. Or, oh, I see. Safer? Both of them are safe, bro. This one won't throw an error. Safer. How do fix? Use the installer and it didn't demand anything out of me. Well, like, I guess the installer does take care of a lot of the stuff, but like it's very different to start from nothing rather than to start from bloat. I need to install my own web browser. Like, yeah, like instead of like Internet Explorer is used to download Google Chrome, it's like you just directly download Google Chrome, right? Just kidding, Firefox. The installer used to suck. I used it in 2021, so haha. Written in Python. How do I make this better? So this is irrelevant. Doesn't really matter. This one could totally benefit because this is going to become a dude. Yeah. Holy smokes. What? Oh. Why did I? Oh. Hmm. I. Oh. Okay, so we actually have the data here. Hmm. Mm-hmm. Yes. Yes. Okay, I'm going here. Oh, did I do it right? Okay, so look. So right here it goes like, string. You've allocated a new string. You goof. And then it goes into right here. It becomes a Euster. That was a cool sound effect. So what we can do instead is make a very cool function. No way. We can do a read zero copy string. Haha, yes. And then instead of like being all good and nice, it's Okay, so we should totally write it like this style. I'm gonna like, let's see, where do you go? You go down to there. You're gonna do Z strings. What the heck? What is that? Zero allocation string builder.net. C#. Zero copy string. Okay. Okay, so this is right. Should we do it all the way at the bottom? Oh, it's not even at the bottom. Transform. Okay, so here's a bunch of like goober functions now. So we're gonna make a trait. Call it RBX read slice Slice is 0 copy or something stupid like that. Okay, so then we have two functions. We have cool people and yeah, so it's gonna be like impl boom for boom. Boom, and then you read string. Gonna make your own string? Nah. Okay, so this is mut self, but we know that self is a reference to bytes. Is an immutable. So it's like this. Oh, it's a mutable reference to a slice of bytes. So is it really a trait? It kind of is, I guess. Self. So how do we know that? Copy. You don't want to copy. Is this really a trait? I don't know if I can actually do this with a trait, because like you would need to specify the type of self here. And then like, is it really a trait? Like I don't think you can go like this, right? Oh, that was stupid. Because like self. Yeah. Invalid self parameter. Self box. It's a type that dereferences to it. Self. Oh. Yeah, I think this is just a function. So, so we have a like that, and then we have so we're gonna need two life chimes, or I guess maybe just one. Yeah, buddy. And then we go like, it returns a, it's a, and then IO result. I don't think so. Oh, I see. Slice. Okay, I think this is cool. Okay, so this guy goes like, yo, I'm gonna move the byte pointer up. I'm reading the slice. And then, so it all works. This is like what the types were already. But because we have a concrete type, we can go like, and we can do split at. You, watching this. Okay, watch this. Slice dot split at lamb as you size. There's no question mark. It is a infallible. Oh no, it is. It panics. Oh. Okay, so maybe check. I mean, it's not supposed to. So like it would only panic if it's an invalid file. Okay, so watch this. We can do equals, something equals. So we have, oh, do we need let? Okay, let out, I guess, and then out. Okay, so the left half, yeah, okay, so this is out and slice equals, can we, okay. Yes. Okay. Juiced. Absolutely juiced. Okay. So this guy, so we have a slice. It's some bytes, and it goes like boop. It reads 4 bytes and bumps the start of the slice. It shrinks the slice to do that, and then this one splits it at length and then goes like, oh yeah, this you can have this as long as A is valid, and then the rest of it is it's bumped again. Everything is like amazing, incredible, incredible. Okay, so that's amazing. Very nice, very nice. Big, it's beautiful. Okay. How do I? Okay, it's just like Scubert functions like this. So read binary string 0 copy, and then read string 0 copy. No way. So we do the same thing. Hello. And then we do the same thing. Hello. And then what is it? Okay, what was the code? Who did this? Oh my god. It's read to string. So does IO have an error for that? Default read to string, append to string, unsafe, where default. Okay, ooh, no, that we do not call read to end here. We are passing to fill it up arbitrary overwrite the entire concept vector, not just append to it. Okay, to prevent extraneously checking the UTF-8-ness of the entire buffer, we pass it to our hard-coded default read to end implementation, which we know is guaranteed to only read data into the end of the buffer. Checked add. What the hell? Serve mini masters. What? Oh my god, bro. Extend from slice. Okay, where's the oh, I see. This is just a function definition inside. Okay, so where does the UTF-8 come into play? That's what I want to know. Borrowed buff. Good god. Nasty. Serving many masters. Saturating mul. Good god. Default read to end. Default read to string. Yes, okay. So what about then here? I guess it's here, yeah. Oh, yo. Okay, so then is error invalid UTF-8. So this is stdio error invalid UTF-8. Okay. So then, can we build one of those manually? Can we say like, oh no, there's no UTF-8, and then that's great. A stir. So we can go like, let okay stir, no way, equals to core stir from UTF-8 out, else return error, std io error. I want that guy. It's pub crate const. Is error and then ret. Const error. Pub crate. I would love to just return one of those. Damn. Damn. From rar error. New error kind. Let's go. Error kind. Who did this? Error kind. IO error kind UTF-8. Invalid data. Invalid data. Okay, so we just copy what it's doing, I guess. Haha, yes. Haha, yes. Okay. Cool. Error new. Cool, cool, cool. And then it's allowed. Oh, I need the ah. Okay, and then it's not a trait. Pub. Pub. Yeah. Okay, so we have our zero copy function. So it as long as we start with a slice, then we can create. We can save the world. Who is it? It's right here. Right here. Cargo format. Yeah. Okay. So cool. Okay. Look at how nice that is. Okay, so state. Oh goodness. Oh goodness. Yeah, so we have to basically, if you have this, then it's better to do different. But like, you can't really do any better in this case. It's like whatever. Because it's the metadata has to outlive the chunk, so you can't do it. Unlucky. Like if we took it higher, then maybe, but instance, no way. So we're gonna do yes sir, read freaking read zero copy. Ooh, let's go. And then boom. Oh, I see. And then we get a stir. Ooh, and then it's already a stir, so we don't need to do the as stir. And we also know for sure that it will live until the end of this scope because the dang thing is right there. Copy saved. Let's go. Okay. Next. No way. Okay, decode prop chunk. Prop name, prop name, prop name, prop name, prop name into. Boom! Right here. Here we go. 0. Copy. Yes. And then, so once again, it's already a stir. Don't need to do that. Oh! It appears to have caused. Can you see that? It's like under the camera. Look at the errors all down the side. Okay. Well, 0 copy comes at a cost, but like you can literally see it. Okay. Zero cost. Surely. Okay, so clone, we can now do 2 owned. Please don't do 2 lowercase. Yeah. Oh my god. Prop name, mismatch. Like, why does it keep doing? Okay, probably I'm gonna need this on my clipboard. Hee-hoo. So this is the sad path when you hit an error. Why don't I just absolutely blast this onto my clipboard, because it seems like that's what's going on here. Clone. Let's go. Bad rotational ID. Prop type mismatch. Okay, this isn't so bad. I just have to paste this 12,000 times without thinking. Oh. Shack attack is nice. And every single one of them was that kind of error. Okay. Okay, do we have a branch here? Who is this? Branch is Scratch. Nah, it's not. That's a lie. We're gonna call it to 0 copy. We already have a branch called 0 copy. Read slice 0 copy. I hacking love 0 copy. Let's go. So that's the sad path. Oh, it's lucky that they pre-grab a string of the slice of the entire chunk. Core. Binary string is okay. Look more. Read string. So this one is unlucky. Can't really do it. Value read string state. Is that value. Content ID from. So that you just kind of have to add property content ID from string. It has to be owned, get owned. Value into binary string into, yeah. It's like getting owned. The data is getting owned. Oh, wait. You can scroll. You can just like scroll wheel this, and it's like scrolls to the next. I didn't know that. Okay, I think well, I guess I'll keep looking. Family. Okay, is this an opportunity? Who did this? Family. Font, family, string. Cached. Is empty, none. I mean, that can be slightly faster. You can like only do this in this path. Cached. ID is a string. We won't talk about that. I think. I mean, this is probably not common. But like it's still faster to avoid. Well, no, actually it's not. Creating an empty string is free. We won't touch it. We won't touch it. Lies. Okay, vecdeck URIs. What the hell? URIs? The what? Content. Wow. Count. We are advised by Roblox. Push front pop back. It's not a loop. Push front pop back. What in the tarnation? Why is there multiple? Interleaved. Okay, hold on. Is this like multiple properties? Variant type. This is like very confusing. Pop back. 4. Referent. Oh goodness, goodness, goodness. What? Okay, so Roblox is attempting to pack these together, which like that's a good thing to do in a file format, but like Jesus. Push front. Ugh. Mutt. That is very fancy. Very, very fancy. Huh. Hmm. Okay, and it's just constructed. So this is probably, I don't know. Can you? I wonder if the compiler can figure that out, because like it's making a vec, turning into a vec deck, and then making it contiguous, all of which should be happy path free operations. I don't know if you can actually omit the sad path code though. Even though I don't know. Hopefully. Okay, so this is. It looks like every single one of them has to be owned. It's gonna go into a thingy. So like it has to be owned anyways. Can't make it good. Cool. Okay, so that was the last one. Oh, entries. Text deserializer. Key value entries push. Entries. Chunk. Decoded chunk. Meta chunk. Okay, this is... Oh, reader. Is there multiple of these? No. As slice. So it's written for read. Oh. But it's only called with bytes. Unwrap. Why unwrap? Is this like ancient technology? Why is there no error? What the hell? Oh, decode. Oh, this is the text goober. Okay, so we don't actually care about this. Okay. Okay, reader read string. What the hell? Types attributes reader. Is that from? Oh, types. Oh, okay. Value R. Who did this? Read attributes. Between map string. Yeah, it looks unlucky. So we can save it in that one spot where it really mattered. Well, potentially really mattered. But it doesn't look like we're going to get anything else. Okay, so what about the binary string? Might... There might be something. Shared string new. Vec U8. Does this guy, like, change it? Arc from data, arc from data? No, it's got to be like that. What's this? Prop name. Oh. Smells like fruit juice. Lassie. As ref. Hold up. Hold up. Wait a minute. Hold up. I think this can work. We can zero copy this. Yeah. And then this guy will error at me. All. But so true. Very true. Absolute true. It doesn't. So this is as ref. I mean, it's useless code. Let's go. Okay, so that actually saves a copy. It's well, for referent and reference. Prop name equals name. I mean, potentially that helps. Cause like everything has a name, so sick. Let's go. Okay, what about who did this? Binary string. Oh, it's the same thing. Where did he go? String, read binary. Yeah. Yeah. Wait. Oh. Oh, wait. Oh, it's already one of these. We don't need to do that. Nice. Dude, this is going great. I kind of want to do it separate, though. Let's do... write 0 copy slice readers. No way. And then yeah, so this one we can add after, I think. Yeah. Okay, so let's do it after. Okay. You use 0 copy string for type name. No way. So we'll just do this first, and then put it back, and then so string bomb, type name bomb, u bomb, string. Oh, is that like crazy? Okay, so that was the easy good one. And then use 0 copy for prop name. No way. And then this is the insane one. Prop name. Okay, that's the other thingy. And then to own. Oh no. Oh no. So it sort of prevents the spam, right? Because then you can look at this by itself. That's the niceness of having comments. So like this one, easy to read, cool, there's code. Then this one, easy to read, cool, there's code. This one, all right, so you do this, and then all of these are the same. There's no like other weirdness sprinkled into this comment. We can put the weirdness in this next comment. Let's go. Okay, so find it. Find it. Yes, yes. Why is this question mark like gray? What? Okay, that's, we can't fix that, unfortunate. Maybe. Binary string into value into. Yeah. Yeah, okay. What about you? Tags decode buffer. Buffer as ref. Buffer as ref, you say? As ref? You only need a reference, you say? If you only need a reference, why don't you just make a reference? Oh, it's a mutable reference. Yeah. Yeah. Another one. Buffer as slice. It's so inconsistent. Okay, from reader as slice. You. That is some wacky code. Okay, so let's try it. So mutt, and then, dude, oh my god, that is horrible code. That is actually valid. So it like zero copy reads the slice and then reads a binary string off the slice. Oh, that wouldn't actually work because it reads the length value. All right, so as slice is a repeated thing from. Let's go. Saving those copies. Let's go. Gaming. Okay, decode buffer. Okay, did I miss something on the last guy? Yes, no. Buffer. Oh. No. We're all good. All good. Okay. Okay, so the very next one. Weed from string. Weed. Mutt. Boom. And then we don't need this. And brilliant. Text deserializer. Yeah, I know he wants one of those. Values push. Roblox string. Groblox. What is that? Yeah, not happening. Okay, brilliant. Okay, let's do one of these. Oh dear. Oh, that's ugly. Brilliant. Let's go. Why did I have to mess with this, man? I love zero copy. Let's go. Okay. Does it work? I don't know. I think it will work. Does it actually work, though? Woo, it does work. It should be, like, measurably faster. What's it called when you have things staggered? Is it just staggered? There's I think there's a cooler like race car word for that when it's like there's things on both sides. Interleaved type word. There's a cooler word. I'm splitting the same stuff out into comments. So all of these say to owned. So that there's no surprises when you see this stuff. Let's go. Okay. Okay. In order to do benchmarks properly, God, that was fun. I actually saved the copy. Let's go. It was so hard to come up with that. Actually, it wasn't that hard. I just had to try. Instead of just thinking about it, I had to actually try to do it. Okay, what am I doing? Right. Okay, I need to... CPU freak. All right. So here's what we do. Tell me what my scaling governor is. Okay. Shh. What is okay? What power save? Oh my god, bro. So then, if we look at the CPU cores, I guess actually this one would be better for this. We can see the frequency here says, oh, it dips down quite low. So if I go like, put performance as my governor, permission denied. So true, so true, so true. Do I need to, oh, I probably need to like put it here. There we go. So now if I look at this, it had no effect. Yeah. What if we, does it, it all says performance. Is that going to help my benchmarks be consistent? Like, I don't actually care if it makes them faster. What I care about is it makes them consistent, because I had like a problem with inconsistent benchmarks. Okay, I'm uploading this code. Hooray! And then we go to Mashta branch. Pushing. Hello? GitHub? Hello? GitHub? I'll be right back. I'm gonna put this away. Look at this dumbass thing I bought. What? What? I bought a bunch of sausages. I was like, yeah, I want that. I hope I can eat it before they all go bad. at that cheese sausage milk meta. Yeah. Okay. That was irritating that it took so long to do that. I could have been running the benchmark the whole time. Okay. Oh. Okay, so we can do cargo bench, and it should work. Should tell me. Benchmark numbers. It should be like faster. Okay, this is just the reference benchmark. So I'm gonna benchmark it before, and then I'm gonna benchmark it after. I don't remember what I benchmarked before. Apparently it was faster, whatever it was. This is a good CPU. Just pepperoni. I can relate to that. Yup. Shack attack while benchmarking. Oh. So it doesn't look like my scaling governor worked here. Power save though? Really? I gotta do like AMD P state. Oh, is it runtime only? Cool. Okay. So then we go do the cool new code for cool people. Very cool. And it should be measurably faster. If it's not, then I majorly have made a major league problem. Serialize is the same. Oh, the only code change is deserialize. Oh yeah. Why don't I write a little documentation on the thing here? Split at can panic if the slice is shorter than length, but we do not expect that to happen because the file a little bit of documentations. Whoa! Okay, no, that's the janky benchmark actually. Very faster. So this shouldn't be different. This is another janky benchmark that keeps flip-flopping up and down. This one should be faster. It wasn't faster? Come on, bro. Can we do AMD P state? Invalid argument. Oh, I said an underscore? Alright. Linux. Set AMD P state governor. Oh. Ah. Ah. Why was it power save? Depending on the server, these covers will be loaded by default. Schedutil. The what? See the above note is equivalent to Schedutil. Okay. Oh. Is that real? Can you actually just do that? Oh, CPU power. Nope, you can't. Unlucky. Why is that different? Let's go this one. I don't know. It just doesn't matter. Go away. Invalid. What? Okay. I don't know why it's power save, but well, it looks like that's the default. Hmm. Okay, I don't really know how to make. Okay, actually I should do more documentation here. So, uh, um, um, unlike RBX read ext boing boing read string. This function only operates on byte slice. Wow. 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 Ah. Oh. it's so good. All right, gonna put the doc on the first comment. Any mistakes? Nope. Cool. Okay, this is just adding documentation. All right, pull request time. So what exactly did I do? I optimized reading instance name and property name. And reference. How do I describe this pull request? I already have one doing zero copy. I'm all about that zero copy. You know how it is. I already have one. Oh yeah, zero copy and reflection database. Okay. Um. Um. Eh. So it's like introduce zero copy variants of read binary string. But like that's such a long pull request title. Oh, zero copy slice readers. Ooh, that's a gaming title. This implements reading a slice chunks of a slice bunks. This splits off chunks byte slice instead of allocating a string or vec UA where applicable. It's wild. Like how would this one be almost twice as fast, but then this one that's doing almost the same thing is like unaffected? Doesn't make any sense. And like this one shouldn't be affected. There are several different classes of changes here that are interlaced. This is why I wanted the cool word staggered. What is up with dictionary sites? Akimbo. I think it might be staggered. Yeah, they don't know what it means. Okay. Interlaced. Interlaced, so but I have grouped similar changes by comment to make it easier to review. The repetitive changes. Oh Lord. Isn't that beautiful? Zero copy in Rust is just like A and you're done. And like all the like it's I read an article that's like doing zero copy in other languages is like immoral. Like why would you do that? That's just like asking for trouble with memory safety. But in Rust, A and you're done. Could call it like read slice. You could say read string slice instead of zero copy. That might make more sense. Uh-oh. Uh-oh. I think that's a much better function name. Not gonna lie. Okay, so yep. And then there's this guy. Yes. Okay. So then we can do. Yeah, this part's gonna be tough. I think I'll just like edit the comment and then and it'll work. Should be all binary string. Okay, so rename the functions. Type name prop name, and then binary string. And then here, oh no, here, edit contents. So this is not called this, it's called slice. Yes. And then continue rebase conflict. Just insert the new one, but with the old one. Actually, we can totally just do both right here. Yeah. Oops. You got me. Surely I got it. Okay. Format. Ooh. Well, that's nice. Nice, nice. That's a much better function name. Okay, so just the function name changed. Just the function names. Cool. Okay, so does it still work? You know what? I should test it on each comment. I guess I should test it fully first. Cargo test release. Surely. Cool. Okay. Check out this test. Unused. Well, obviously it's gonna work. Check out comment. Nice. Huge. And this one already works. Okay. Okay, that's a better. Nice. Okay. Cool. Not a draft. I absolutely hate that GitHub remembers this because I don't remember to change the button. Oh. Oh, nice. Okay. Another pull request. Let's go. It's this library is asking to get fix-ups. Little optimizations here and there. Yay. I'm a gamer. Oh, splits off chunks of. Oh, okay. Well, that was fun. I that was I think that's kind of giving me closure for this library, even though I didn't. My like big rewrite is never getting in. It doesn't really belong in the library. That's not what the library authors want. It is potentially faster, but it's way more complicated. I think that they used Euster because they didn't want to expose lifetimes, because that would be a lot of rewriting for the library consumers. But like that's the correct thing to do. That's the correct data model. So, and then you don't have any memory leaks like Euster. But you could, instead of having a string interner, you could have zero copy references to the file. If you just provide a byte size, it could be better. It could be better. Brilliant. I'm absolutely spamming this repository with pull requests. 1, 2, 3, 4, 5, 6, 7. How many have they accepted by me? 1, 2, 3, 4, 5. Wow, they actually accepted this one? That took a lot of discussion and time to get in. When was it opened? September 26th, and it was merged what was that activity? Oh, January. Yeah, January to September. It took almost a year. It was open a long time. It's really fun contributing to this repository. They have a high standard for like not breaking things for their users, and like they're not excited about changing things for the sake of changing things, I guess. I'm kind of excited about that. It's like, oh, I think I can make it a 1% better if I change everything. Which kind of makes me a bad library author. Brilliant. I'm happy with that. Closure. That's a funny way of putting contributing to an open source project. Ah, I did not really want to stream today, but I just enjoy programming so much that it's like, it's like a loss to not do it. Because it's my work habit. Yeah, I didn't want to like directly dive all the way to the deep end of like figuring out physics bugs and stuff. You know what? Why don't I go to the union thing? The union. Union. God, I'm such a gamer. Programming is so fun. I love it so much. Where do they do the weird... Oh yeah, F32 to bits, rotate left. Oh, really? Rotation. Okay, so this is the stupid Roblox float format then? Very nice. That is clean. Sorry. What is this one? What? Oh, it's the... Okay, I'm stupid. Well, I'm happy I did something. I'm extra happy that I figured out a way to zero copy some of that stuff, because like that was bugging me so hard. I don't think the code path was exactly what I expected though. The Roblox file format, it looks like it's doing like strange grouping of properties and stuff, so it can deduplicate the name stuff instead of repeating it so often, which I did not understand, even though I looked through a lot of the code. Oh, dude, I could do this as well. Zero. So the reflector, I kind of dumped on the code a little bit and made it all memory leak everywhere. How many memory leaks I had? String leak. I wish it would tell me how many. Oh, 12? Yeah. So instead of like string interment or something, I just kind of memory leaked it. I mean, it's kind of hard to do it another way, because like it has to be a permanent immutable reference. Bump allocator is actually just the way. Well, hold on. Dump property name. Well, hold on. Wait a minute. Wait a minute. Wait a minute. I could do this proper, couldn't I? So we go here. Yes, API dump. So if we zero copy this, then it holds references to the dump file, which definitely outlives the database. And that's how you can do it. Wait. Can you took... Is it constructing these as it goes? Or does it make the big chungus at the beginning? Dump. Dump. Hello? Dump. 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 I mean, it does outlive it. Okay, so is that because it's like cascading down the references and it doesn't have an A? So wait. Meetings. Yeah. I think I can game this super hard. Okay, so let's do DB. So the database lives for DB. That's just great. But the dump also lives for DB. So then if we take any references, they're valid for the same amount of time as the DB. So we just do as stir straight out of the dump, and it's good. And we don't have to do memory leaks. Memory type name. Who did this? Dump property. Yeah. We just like as stir everywhere instead. And because I specified that it's going to outlive it, it's like, oh yeah, dude. Yeah, anytime, man. Yeah, that looks good, dude. Hell yeah, man. The Aster. Y'all gotta love the Asters. Wait. Reference, okay. Class name. Boom. Aster. Boom. No more memory leak. Don't memory leak. Dump enum. Dumpy. S. Leaky. Okay, that get rid of all the dems. Almost. Defaults. What you doing? Database instance. So basically, apply instance defaults weak uster toString. So who I mean default literally it's already a memory leak. Like what are you doing? Just Astor should be fine. Is it a reference? Yeah, it's a reference to a user. Oh. Why didn't it want that? See? Like what? XD. Okay. Next memory leak. Patches. Boom. Okay, so function signature says database anyhow apply post. Who is this? Patches. Okay, so what we can say is the patches lives for at least as long as the database, and then we're free to dump stuff from patches into the database because it lives. It lives. Descendant clone. Nah. Ass. See? Okay. And that is not all. Close. So who are you? No. We're going to do explicitly database lifetime here. And then say this makes a database. Enum leak clone. Nah. Yeah. DB self. I believe self is correct. Holy smoking donuts. Okay. And then you don't like it? Yeah, because... Okay, it's patches. We got the database lifetime. And then everything was good. Yeah! Who's next? Memory leak. Okay. Self. I think this can work, DB. Because, like, we have a borrow here. Oops. Okay, GG. And then... Yes. Okay, so this is different. Because we don't... I think we can borrow it here. So if we say the database... like that, and then... Please! Ow! Data moved. Who... What does this look like? Baba B. Oh, string. Wait a minute. Wait a minute. String. Nah. That's an A star. I guess that's a different change. Ah! Wait, no, this is the change. Okay. Yeah, no. This is the big lifetime thing. I just have to put that with the other similar changes. What is that? And then we have to borrow this sucker right here. Borrow. CRD. Borrow. No way. And then... does it care? No. Uh-oh. Not hard? GG? Okay, so... missed string. And then... Anybody else have a string? Searching. I believe I have made a mistake here. So we're going to want to filter this by database. Yo, wait, real? Oh, reflection. Class tag from stir error. Yo, I actually zoinked every string. That's crazy. Okay. That was the last remaining string. Okay. So then here we can so then this is not real anymore. We need to actually steal this from here. Is this a mistake? Migration. I don't know. Is it a mistake to not make it pub? I think it is. We can just say it's a mistake. Oh god. Yeah. Okay, so then the reflector patches migrate. Boom, boom, boom. This one is owned. Get owned because we're reading it for something else, and it doesn't have deserialize. And then we don't import Baba B migration like that. Into what? Is that a problem? Why are you trolling me? Data moved here. It is big time trolling. Oh my goodness, somebody has a problem. Okay, so property name into okay, so we want like that. Oh. Missed me with that reference. Okay. Binary also problem. Yes. State also problem. Property, very true. True. As stir. It's already a stir, you goob. Okay, so then where the hell are the comments here? Fix. Okay, so binary. Yeah. Back to the reflector. Migration operation cannot find. Oh, we need that instead, I guess. LMNAPQRS. So that's first. Good. Got him. Okay. Uh-oh. Oh. Can I go like this? Okay, I have to go like this. Ref. Yeah! Okay. Okay, did I miss any changes in others? No. Okay, so this is reflector, fix lazy implementation. By borrowing from, yeah. Yeah. Cool. Okay, so I actually found a mistake. Don't do memory leaks, kids. Okay, so missed string means use zero copy. Yeah. Mistake. So this is all reflection. Yes, sir. Is that it? Oh. To here, surely. Okay. And then reflection database. Is any of that? No. Okay, so then XML is there. And then binary. XML. Oh, jeez. XML. What does the full change here look like? That's gaming. Ain't no borrow. Ain't no thing about it. Property name. Huge. Absolutely massive. Okay, does it work? Ooh. Surely it works. It must work. It only took me half an hour. Wow. Okay, this should be close to the this guy. Yeah, it's close. But with that fixed thing, cool. Okay. And then this is actually fixing the lazy implementation. So I haven't actually reviewed this, so. Cool. So I didn't end up needing a bump allocator. I'm glad I didn't put that together because I wouldn't have. Tried again. Brilliant. Brilliant. Yeah, all you need is lifetimes. Rust lifetimes, so good. Safe. No use after free. And then the other one as well, I don't remember what it's called. Null pointer deref. There's two. Use after free and double free. That's it. Doesn't happen. Uh-oh. Yeah. Okay. Yeah, do it. Do it. Just do it. Thanks. Thanks, gamer. Wait, Elid? Okay, so what has changed here? XML. Oh, I see. Come on, man. Okay, just do it. Okay, just do it. Surely. Okay, test. Huge. Okay. Clippy. Gaming. Sometimes we're not successful. Yes. Not the sausage in the between the teeth. Oh, I got it. It's still there. Excellent. Hmm. Something Trey does as well. Hmm. I guess I picked it up from him. Wow. No way. They should have done this from the beginning. Why wasn't it already like this? Not a mistake in sight. Forgot about that one. I'm gonna make a special note for this. The migration field of property migration is made pub. Put a little dot there. Oh. People reviewing. What happened? Change overall degrades performance. Oof. I don't know what that means. Okay, so this is iteration time. Okay, so this is GNU plot, I think. I did try. I tried to like fix the scaling governor thing. No. I still saw a 10% difference in the serialized benchmark. I guess it's gone now, but yeah. But why didn't it flatten out the CPU thing? Oh, dude, look at that. 2 GPUs. So cool. Oh, you can't see it. It's behind my camera. Oh, you can see it. It's just peeking out over the top. This one is always using a crazy amount of power. Does it show power usage for the CPU? I don't see it. Didn't hit 3 hours yet? I'm trying to hit 3 hours and I'm gonna want to watch TV. Cache locality. Dude, I gotta install GNU plot. Let's go. Yes, sir. Okay, so then Ew. So now I can do more benchmark. Let's see. Linux set CPU frequency to max. CPU power. Okay, who does CPU power? I forget how you do this. CPU power is not found. Yeah, so I want to know. Okay. Orange. Well, Pacman, which package provides file? I've searched this so many times. QO, obviously. Why didn't I think of that? Obviously. CPU power. Okay, what about bin? User bin? Okay. Package file. Alright, screw it. Wait, what? It's actually just a package. Nope. Okay. Alright. Ooh, man page. Okay. Options. Can I just say, like... Okay, does it say whether it survives boot, reboot? Because, like... I don't really want it to mess with my system permanently, you know? Can you read it? Frequency set. Is there frequency info? Cool. CPU power frequency info. Oh! It's using the cool guy. Why is there 31 and not 32? Hardware limits 5.09. We should go like 5 gigahertz. Current CPU frequency. What is that? Does CPU power survive reboots? Linux. Oh. On boot. Yeah. Running CPU power frequency set G power save as a one shot. CPU power changes don't persist. Yeah. Ah, excellent. Okay. So I can safely destroy these settings and nothing will happen. Okay, so we want to see the current frequency. Yeah. CPU power, help. Frequency set. So, how about we set the minimum frequency, a specific frequency to be set. Do you say like gigahertz or something? Ah, yes. Okay. Cool. So let's say frequency set f 5.0 gigahertz. Root. So true. So true, gamer. Okay. Min. What? It said. Oh dear. All right. Whatever. Surely. I don't think I got it. Why? Okay. Let's do G. Performance with the W. It's still dipping down, you know. You hear? So I don't know what the I guess I didn't see the 70%, or did I see the 70% thing? It said 80%. Yeah, I think I did see it. So I've messed with my CPU frequency and it doesn't seem to be doing anything. Is it because it can't reach that frequency? Or is it... Well, it's doing 5 gigahertz there. Oh, dude, are we gonna get a GNU plot? Hell yeah. I want to see the GNU plot. What does it say at the top here? Running tests. So it used to print out cannot find GNU plot. I'm guessing it found it, so it didn't print that out, and it's gonna make me a cool graph. It's a cool graph. It's cool, guy. Oh, I gotta stop sitting in my chair weird. I'm breaking my back. I got this chair so that I could have a fixed back. So this is the comparison benchmark. I don't think I fixed it. What is this? Oh, that's the paint. There's paint on this shirt. It's gray paint, so it looks kind of like the shirt, but oh, it comes off. Oh. Oh my goodness. Okay, so then the entry branch, appease Clippy. That one had a change. Okay, what was properties? Yes. Let's see if we can get a negative result from this. We could also look at who is using this. I see. Well, no, those are just tests. Yeah, I don't really use this. Okay, so it's not used in the code. Add property is there, but that's a migration. That's kind of rare. Okay, well, I am not seeing the like crazy percentage here at least. Oh. Is that the one that had the crazy percentage? Yes, it is. Yeah, that's the one that's the crazy percentage. So I'm still seeing the problem. Unless, like, I mean, it's kind of repeatable. Wait, serialize. Are there any serialization changes here? No. It's deserialize. Builder. Yeah, shouldn't be any serialization changes. I'm still getting positive results. I don't really know how to fix my benchmarks. Still getting those positive results. Maybe you should just stop using an inferior operating system. But look at this awesome plot. Oh, does it? Wait. Well, I gotta see my plot, you know? Cargo bench GNU plot location. Oh, do you have to like pass plot flag or something? It's already been fixed. Where do you suppose the plot goes? Oh. 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 SVG. Render it. Reveal in file manager. Oh, we got them plots. Index. Surely. Ooh. Yeah, so he screenshotted this guy right here. Which one is blue? Which one is red? Understanding this, the plot on the left displays. Click on the plot for a larger view. Oh snap! Oh, there it is. So base new, base new. So average time. So lower is better. That. Oh, it's 1.8. I was like, that is a lot lower. Okay, so the scale got me. Huh. Probability density function. Fascinating. Base mean. I mean, that definitely looks like it's getting better. It's consistent for me. Okay, what if I just run it again? Let's see if I can get it to be weird. And like it'll go like or something. Here's the wacky one. We might see minus 60% or something, even though nothing's changed. Okay, well, it looks... So what makes me upset is, oh, it's 5.0. What it makes me upset is that this is like changing. I want it to not be changing while I'm running benchmarks. I want to have like a flat gigahertz. You hear? Diddly 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 diddly. He's gonna say it. So that was the same. Let's run it again. Why would every single branch I make be 70% faster than the master branch? That doesn't make sense. Like, I've seen it on the entry branch here. I've seen it on the zero copy branches. I've seen it on the... It just doesn't make sense that, like, making random changes in random places that are unrelated would all have the same insane performance increase. But it also seems like the master branch never has that huge actively mad at being good. The just like tiniest change. So that's a pretty big variance right there, 5%. So that is very well could be from moving my mouse differently, like background tasks and stuff. Hmm. Radio. Hmm. Can you imagine if they were benchmarking it wrong? That'd be insane. Unlikely. I can't get the CPU to stay at a fixed frequency. I remember I watched an hour-long video about BIOS settings yesterday. That was fun. And there was one setting where there was deterministic power usage and deterministic performance. And it was the people who made the BIOS. That's why it was such an interesting video. And they said that people always called them saying like, I picked the performance setting. Why am I getting worse performance? But it's deterministic performance, not better performance. So it's like across your entire fleet of CPUs, you can expect the same performance across if you run the same workload. So it like goes to the lowest common denominator. Bruh. Like is it actually just hitting a Windows bug or something? And it's like by building a vec in between, it's like bypassing some stupid Windows thing. That just seems so unlikely. Like Windows is so battle tested, just like Linux. Confusing title. It's a level 1 text video. BIOS masters. Thou. Mad lad. Oh, I can't make it stay good. It's like every branch that I make is 70% faster. Okay, wait. What if I go from one branch to another? So this was the properties branch. What if I go to the entry branch and run it? Like these benchmarks should be pretty meaningless. Because I'm comparing two unrelated changes rather than like compare master to this change and master to that change. I'm just going this change to that change. They should be like random and unrelated. But if we don't see a change in the 1,000 parts deserialize, here it comes. Do we see a 70%? We do. But hold on. If I switch back, do we see an inverse? I guess I should run it again. Buh. How do I hide like the spam that comes after this? Cargo run benchmarks without tests. Benchmarks are built with the test option. Hmm. Can I just say something ridiculous like this? Like, okay, it's ignored. How do I ignore the ignored? Annoying. Okay, did I run it again? No, that was the first time. Okay, so if I run it again, do we see any difference whatsoever? Like more than 5%. They should all look like this with like white numbers, meaning it's not changed. %. It happened. Okay, so I just ran the same benchmark again, and it was 78% faster without changing anything. So what was that? I tested 78% faster. I tried my best. I tried my best to make the CPU governor fixed. Always run at the highest performance. Maybe that's not it. So this is the entry branch.
Yeah.
What if I just keep running properties? So I never saw the performance jump on here. So how would I just keep running it and see if I ever see it? Running benchmarks repeatedly on branch consistent across runs, but running on the branch is not. What about master branch? I wish I could run these, multiple of these at the same time. But like, you can't do that. It's a benchmark. Okay, run it again. Looking good. God, I need to just run this like 5 times. So I should, okay, entry bench is not, I know that. Euster uses pre-calculated hashes, which are the same for every hash map. Could it be accidental quadratic behavior when collecting doing map was map dot header collect. Could it be? Could it perhaps mayhaps be? Okay, that's consistent. So that's 2 runs. I'm gonna do 5 runs. I'm gonna pre-type this. I'm gonna try the master branch. It's a shame. It's a shame. Benchmark. 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 Okay, this is number 3. Looking good. Okay, this is the weird one. consistent instead of inconsistent. City rhythm. I want to b-hop while the benchmarks are going. Benchmarks. Whoa. 23. 23. Bro said 23. Okay, well that's consistent. So then this is number 4. I'll be back. Here it comes. I blame Euster. It's got to be Euster. Doing something funky. Couldn't be me. Okay, benchmark number 4 complete. How many benchmarks would I need to do to get a 5 sigma result? What is that, 5%? So 20? Oh no, it's way stronger than 5%, isn't it? Sigma. Sorry. Yeah, so I'm going to test the master bench next and see if I see it on the master bench as well. Okay, so I did 5 runs, and it didn't be doing like that. Okay. Wenchmark. I love benchmark. It's worse. This branch is worse than my branch. I guess I should like monitor the frequency. Bah. Sweet. I blame Euster. Okay, how is our weird benchmark faster? On faster on master. These shouldn't be different, right? So deserialize does make sense that it's different, but slower goer. Okay, so that was benchmark 1. So that was sort of the initial what's going on. Now I have to do 4 more, and they should all look like this, where it's like unchanged. So I can get the problem to happen on the entries branch so far. And that's happened twice. Where I've seen the issue on the entries branch. Afterglow. Silly song name. Whoa! We saw it. Okay. So So we saw it. So I just ran the master, and then I ran it again, and it was different. But I ran properties 5 times and never saw it. Should I go run properties another 5 times? Do this another time. Okay, here it is. This is the weird one. Do we get the fast version or the slow version? We get the fast version. Or was it the slow version? Is this just, I don't know. The last one was slow. So this is slower. 80% more time. So this is the same slow version. Do it again. Okay, I can't. Okay, I want to compare the fast version to the properties branch. So I've seen it happen. So it didn't happen twice just now, or is this 3 times now? Oh, this would be the 3rd time. If this is a white number, then it is slow for a 3rd time in a row. Okay, it's slow for the 3rd time in a row, if my memory serves. Is this the 4th one? Because like I did 1, 2, and it happened, and then I did another one, and this is the 4th one, I think. I hope it switches back on number 5. At least it's easy enough to make happen. Okay, so that was consistent. Please happen. Please be the fast one. I want to compare it to the properties branch to see if the fast benchmark is faster than the properties branch consistent benchmark. Oh, it's your operating system. It couldn't be our code. But like it's valid. It's so valid. Accusation. Oh my god. Break. Oh! It broke. Okay. Now we can compare the fast version with the properties branch. And my 50% feeling is about right because it was fast, slow, fast, slow. So like a fast, I don't know. It's like, it seems like 3 out of 5 were one way, 2 out of 5 were another way. All right. Did he post the same one? Serialized brown. Alright, what was the last one? Alright, so that's like same. Okay, so we want to see if I go to properties branch, is this slower than the fast run? Check out properties. Bench. So 1 millisecond, 1.8 millisecond. Would you ever make a horror game? Well, I got news for you. I already did. No way. Non-cash grab. Nope, I would not. Well, I would participate in a group of game developers. It's kind of cool. Is next after B-Hop. Well, I wanted it to be the Strafe client. I'm struggling to get back into that right now. That's why I'm like working on this library, is because I find it interesting and it's not the Strafe client. Kind of procrastinating on that. I want to have a like working physics demo. Okay, so there's minus 11%. So on the master bench, when the fast benchmark procs, it is faster than this one. Third person shooter. There's a lot of like procedural animation and like code feel sort of in that. So that's kind of an expert, and it's a very overrepresented genre as well. Well, there's one benchmark. It's said that this is slower. Okay. So I did actually test both 5 times. Five benchmarks on the master or entry fronts. Consistent. Let's do another 5 on this branch. Did I already mention that? Is it quadratic right here? Logic build. Fix your 529. Yeah, but I'm not sure if it's my problem. How we doing? Consistent. Oh. Consistent. Go again. Why do Linux users make the text on their screen bigger? For me, it's because I'm blind. Also because I'm streaming. So, like if you're watching the stream on a phone, if it's not massive, you can't read it. So, get surgery. What if my eyes change again? Isn't it like $10,000? GD script. The more I learn, the less I learn. There's someone way better who has spent way more time. Why should you care about them? Invest in yourself. A catch. I have not heard of that before. Why 400 Ni? I guess like you don't necessarily need it on both eyes, but that's a weird way to put it. Usually think of it as a pair. Get your eyes done. Get your eyes done up. Making my code look nice in case someone has to see it. You see, I don't have that problem. And I'm showing it on stream all the time. I'm just like, and then when it works, okay, next piece, next thing. And then I come back to it. Oh, who wrote this? It's so awful. Okay, so if I run 10 benchmarks, this is number 2 or number 3? I think it's number 3 because the last one I was checking consistency, so it should be number 3. What is the probability that I don't hit it? Oh, was that 10%? I mean, it's not 70%. Clean out their spaghetti code. I mean, you may as well make a new game at that point. Don't want to start from that. SkyTrain. So here's test number 4. Okay, so my comment. Where did my comment go? Oh, here it is. Okay, so if it is 50-50, then that's 2 to the power of 10, and that's 1,024. So it would be 1 in 1,000 to roll slow every time or fast every time. And it's fast in my case. So okay, this is number 4. We do it again. Do it again. And it was consistent again. The last one, and I'll post my comment. I looked up how to set the governor, which supposedly just sets it to always run at the maximum frequency. Consistent? Oh, no, that's not the weird one. 2 more benchmarks. I don't have big arms. I can't do the big arm thing. %. It's consistent. Gym mark. I probably have a good body for going to the gym. My metabolism is insane. Just eat whatever I want, never get fat. Insane. I guess I don't really eat that much though, so whatever I want isn't actually that much. Don't actually want that much. 21. Like the other one was saying 27. Like it's literally faster, bro. Yep. Okay. So the properties branch is 10% slower than master for the fast variant of the XD test. XD per second. Bruh. Bruh. Another W for the Quaternians. This is my W. 0 copy slice readers. Absolute W. I tried to fix it, but I don't actually know if there's anything to fix. Yeah. Hmm. Can you imagine if he actually hit the bug right there and it was like pretending to be slower? Where does Krakow 10 come from? I made it up on the spot. So Krakow turns out to be a city in Poland called Krakow. It used to be the capital of Poland. And it's also in a Calvin and Hobbes comic where he's using it as like a gun sound. Krakow, Krakow. But I only saw both of those. I only learned about both of those after I made it up on the spot. It was a RuneScape username. I was like, I'm going to be called Krakow. And then that wasn't available, so I was Krakow 10. I wish it wasn't my GitHub username, but I've tried to change it, but it just is always that. Quaternions? Quaternions is a math object. It's a set of 4 numbers that can be used to represent rotations in 3D space. I thought they were awesome. There's another username, my oldest one, which I made for StarCraft. Also, I came up with it on the spot. The username is XXX Monkey Man. Monk E Man XXX. That was my username on Roblox as well in 2008. I made this up for StarCraft. It took me 10 seconds to come up with. I was like, what should my username be? XXX Monkey Man XXX. No affiliation with, like, gosh, as a child, I really love monkeys. They sure just, ooh-wee. Nope, just made it up. Well, I'm not sure what's going on. Why doesn't it happen for these guys on the Windows? Roman Legionary. What? Just like that was your imagination? Or something that actually exists? Real. Yeah, no, it's the math thing. Demeternian. Demeter. I don't know what that is. Well, I'm happy. Dime. Oh, dime turnian. I see. Like 10. Dimidome. Comp sci major. I tried to be. They kicked me out, or they didn't kick me out. They turned me down because my English grades weren't high enough. You've got to be good at writing books in order to do computers, apparently. So I just dropped out and taught myself instead. And that's worked out great. Hmm. ELA. What's that? What else can I do? I guess I don't have to work on this thing. Light. My notes say. Where's that coming from? Is it? I didn't need to do that. Yes. Damn, I have a lot of notes about the Hashster library and like Euster and everything. I did that. Huh. My notes get less and less intelligible as they go back up. Like I don't have the context to know what they mean. I was working on the submission system for so long. Didn't get it out this weekend. Yeah. Anybody sending messages? No. I love Shack Attack. Alright. I think that's all I got today. Got 4 today. I'm gonna end the stream. Couch with no TV? Yeah. I have no HDR screens in my house. Can you believe it? Can I even be called a tech guy? I've looked at the store across the street for like a LG C4 or something, but like the prices are never as good as Amazon. I don't want to buy from Amazon. And like they don't have them a lot of the time. I think I saw one once, but it was a giant one for multiple thousands of dollars. Don't buy used. With TVs? What the hell? I mean, they're pretty cheap new, so. So I think I'm going to try and do, I'm going to write this down actually. I'm going to try and do union support, unions broken, strafe client. That's what I'm going to try and do tomorrow. Tuesday. So that's kind of my inroads back into strafe client development, is because it's not that hard of a problem, and I've already identified the issue. It's annoying to fix because like Roblox is being all automatic with the size, and then I was kind of lazy with my implementation, and then it had a compounding issue where like it's like resizing itself automatically, and then based on the automatic size, it's like compounding issue. I just have to like think carefully about it to fix it, and I haven't bothered to do that since I identified the issue. And then hopefully I can get back into strafe client development, back into the trenches of like physics bugs, trying to identify freaking like integer accuracy and like face vertex being like 0.00001 off. Like literally if it's off the face at all, it blows up the algorithm. It has to be exact. I wonder if I can come up with a better way to do the algorithm as well, because it's slow. You can't be running at 400 frames per second. That's not fast enough. Can't be doing like that. TLC, TCL is the brand. Tender care loving. Well, I'm gonna watch my goofy TV show. That's part of the reason why I'm stopping the stream. I really wanted to watch it instead of streaming, but can I just rob someone? Dude, I don't even go outside. I I just avoid confrontation. I proactively avoid confrontation. Secret Garden. Oh. That's the song name. Shack Attack. What show? Resident Alien. Just I have a secret. Oh, I'm an alien. I'm living in a little town. Guilty pleasure. Just stuff. Just want to watch it. Hello. I'm ending. Alright, I'll show you what I done. It wasn't a whole lot. So I wrote this. I found a way to do zero copy on some of the stuff that was annoying me. This read string thing for the Roblox file format. So instead of reading a string, core read string. So here's how the string thing works. String allocate. No. So it does an allocate and then it does a copy. So allocate copy. And then my version so here's my version. Read string slice. So you pass in, is this under the camera? Yeah, it is. So you pass in a mutable reference to an immutable slice of bytes. So you're only allowed to edit the reference. So the reference is mutable, but the underlying bytes are immutable. So it's like, yeah, it's a little bit funky type signature, but that's how it is. Ah, yes, of course. So like how it works, I mean, this is how it works, but so it's returning an immutable reference to some valid UTF-8 bytes within these bytes. So how does it work? So first we shorten the, okay, Shack Attack, a really good song, but I'm explaining. First we shorten the slice. We read 4 bytes off the front. So that, so like if you imagine this is the slice, I'll go like this. If this is the slice and like, it's a mutable reference to an immutable slice of bytes. So you're not allowed to change the bytes, but you can, so if this is your slice, you can go like this, 1, 2, 3, 4. And that's what this does, is it changes the reference to point to these bytes instead of these bytes. So yeah, it shortens the slice. That's why you need the mutable reference to the immutable slice, is because it's changing the underlying bytes. That's so specific. It's really clever though, isn't it? Like, it implements the read trait because it can keep track of its progress by shortening the fat pointer that tracks both the location and the number of bytes it's pointing to. It's very clever. And then we can do the same thing again here. So we just read an integer for length, a U32. What the hell? Roblox uses big endian and little endian in their file format? What the hell, man? Okay, so then after we've shortened it by 4 bytes, we split it at this length. So let's say the length, this is our string, and let's say the length was, what is this? 1, 2, 3, 4, 5, 10. Let's say it was 10. So this is these bytes, and then this is these bytes. So that's what split at does, is it makes 2 of these. It makes 2, I guess I can go into the editor and show you, because like, it'd be easy to like highlight it. Hello? Where is it? What? Huh? Oh, it's this one. Alright, so split at So you see it returns 2 slices, takes in 1 slice, and it splits it into 2 slices. So it writes the second slice, so that's like these characters, to our mutable reference. So it shortens it even more, right? I said like, oh, it reads the first 4 bytes, and then it shortens it even more. So it's just the rest of the string. Whatever the rest of the string is, it's now shortened even more. But we did get the bytes before. So we got these bytes right here. And that's our stir of a specific length. So if this is 10, it splits it, and like, boom, there's our out. And then we try to interpret that as a valid string. And then if that's successful, boom, we got it. And so we never did any copy operations or allocation. 0 copy. Yeah. So, oh, this is probably complicated inside. Split at checked, split at unchecked, pointer. Oh, it's not that bad. So from raw parts. So the pointer before to the midpoint, and then the pointer added to the midpoint plus the rest of the bytes. So it just takes a slice and splits it in 2. And that's just pointer manipulation, right? So you've taken a reference to some bytes and just kind of manipulated the pointers and without having to copy any of the bytes. And then where it's used, so read string slice, this is a stir instead of a string that's been allocated. And then we don't actually ever need to allocate it all of the times it's used here, except for the errors. If it produces an error, the error wants a string. So on the sad path, the error path, we allocate a string. But on the happy path, it stays just a stir slice. And we never allocated because at the very top of the function signature, we had this slice. And you see, it's a mutable variable, but an immutable piece of bytes. You can't edit the underlying data. And then you see it becomes a mutable reference to an immutable slice of bytes right here. Because this guy is an immutable slice of bytes, but I take a mutable reference to the immutable slice of bytes, and then it matches the function signature. I just knew what to do when I wrote it, but it does look pretty wacky if you don't know Rust syntax. Fantastic. No allocation, no copy. 0 copy, 0 allocation. Let's go. 8% faster. Huge. So much resting. And like, this is really bad to do in other languages because like you could easily just like have lifetime errors, but all I do in Rust is say and that's it. It like checks everything, and you are prevented from making mistakes. It handles every possible use after free and like null pointer deref, double free. Like it just doesn't happen. It's just built into the language. Like if I don't specify this, it's like, are you sure you know what you're doing? Are you sure? Wait. It doesn't? How does it know what to do? Oh, there it is. There it is. Okay, missing lifetime specifier. Are you sure? This function signature contains a borrowed value, but the signature does not say which one of slices 2 lifetimes it is borrowed from. Well, actually, it is the inner lifetime it's borrowed from. We can drop this reference while this reference still remains valid for lifetime A after we drop this mutable reference. So it's specifically A here and not A here. Very specific. So yeah. Then I used another version for read binary string slice. So that just cuts the slice and it doesn't check if it's a valid string. Oh, and then it immediately checks if it's a valid string. Nice. Okay. But it doesn't need it to be a string, and it was a string before. It allocated a string, it copied it into the string. It didn't need to do either of those. It just needs the reference. So this is like, it's better. Explicit lifetime requirements. Yes. And then like, oh no. There's so many errors. So yeah, that was my main accomplishment today. And then I also went through and tried to make my benchmarks consistent. So this guy posted this. He's like, this is actually a bad change, and it could very well be on a different platform that's a bad change. But not on my CPU, but on my computer. So I discovered how to make the CPU not go slow, just in case that's what was happening. But I ran the benchmark on this branch 10 times, and it was within 5%. But running it just 5 times on both these branches, it was like varied 70%. Sometimes. Like 50% of the time is fast, 50% of the time is slow. So I don't know if it's the operating system being weird during the benchmark. Like, did I just hit 1 in 1,000? Probably not. 2 to the power of 10. I blame Euster, honestly. Anyways, I'm going to go watch my silly show. There's 3 seasons. I'm not going to finish it today, so I'll probably be distracted again. But I'm going to try and wean myself back into doing Strafe client work. The physics, you just can't fall through the ground. That's just a bad time. It can't be doing like that. Rampage on the DOM repo. Yeah. Author. I have 7 open pull requests. Justice. And I have 1,000 lines of code. Oh, you didn't see it. 7 open pull requests. Yeah. I have 1,000 lines of code that I haven't submitted, but probably they would reject. They probably chose to use the Euster crate. I hope I can convince them that Euster is bad, and then they change the API to get rid of Euster and use my code. Use my code. I made it work. Yeah. All right. That's all for today. I'll be back tomorrow. I'll try and work on Strafe Client. See ya.